Hey, what's up? It is Wednesday, May 4th, 2022. We are powering into May, still in the beginning, and yeah, we're here at Coding with Shaft, or Shaft the Algo Man. I still haven't decided the name of this channel, and we're trying to, solve some algo questions. And so if you like my content, just a reminder before I get into it, please like, subscribe, and comment below. Let me know how I'm doing. Let me know what you want to see. And yeah, let's get into it. It's a gloomy day, so kind of perfect for algorithms. And yeah, I'm ready to do mediums now. Well, not totally, but a bit, right? Like I want to try to explain these as I go through them. I've been doing a ton of mediums as they are, but explaining them sometimes gets a little tricky once you get into the CS of it. But yeah, in this case, I think we should be good to go. So let's see, the name of the problem is max number of k-sum pairs. Okay, 1, 6, 7, 9, it's the daily challenge. All right, and I have a discussion thread on it, which I'll share in the link, a tweet, whatever. So you can follow me on Twitter, follow me on this channel, and you'll get to see all the discussions and whatnot for each of the problems. Okay, all right, and the discussions are in Leetcode. So here we go. It's a medium problem. It's a very well-liked problem. Okay, and the problem states you are given an integer number nums and an integer k. In one operation, you can pick two numbers from the array whose sum equals k and remove them from the array. Return the maximum number of operations you can perform on the array. Okay, and then the example one they give you is 1, 2, 3, 4, and k equals 5. So you have to find the maximum number of operations such that if you take two of these elements out, they sum to the target. So if I take 1 and 4 out, they sum to 5. And then if I take 2 and 3 out, they sum to 5. Okay, so that's two operations, and that's the maximum. Okay, this is kind of intuitive, I think. Some elements of it are, but the question is, how do we know that we're doing the maximum number of operations? Okay, so the next example is 3, 1, 3, 4, 3. So if we take, and notice that there can be duplicates in this array, right? So if we take 2 3s and sum it to 6, we get one operation. Then we can't use these 3s again, so we can take 1 and 4, that will sum to 5, 1 and 3, that'll sum to 5, 4 and 3, or 4 and 3 will sum to 7. So none of the remainder of pairs of numbers that we can use can sum to the target 6. Okay, so so how do we go about writing an algorithm for this? So the thing you want to intuitively understand, you look at the array and you I think the first example really gives a good solution. It gives a hint to a good solution, because you see what's true about this array. It's sorted, right? And it being sorted lets us pick elements from the larger and smaller sides of the array, right? And sum them together. And that also simultaneously lets us, as we move along the array, squeezing inwards, right? We can also use the fact that the elements are sorted to start to look at which sums don't fit into the criteria. Okay, so let's see here. Okay, so here's an example. If I have 1, I'll start at the ends of the array, and 4, right? The pointers are 0 and 3. Let's say we have 2 pointers, right? 1 and 4 sums to 5. So then we go to the array, we can move both numbers ahead. We can move the left pointer left plus plus and the right pointer right minus minus. And then two inner numbers also sum to 5. Okay. And so that's a pretty straightforward example. Okay, and you don't yet see the efficacy of sorting here, right? But you'll see in a second. So if I take nums, and I'm gonna sort the list 3, 3, 3, 3, 4. Okay, and that's this list sorted. If I sort this list, I get now let's go through the same operation. Remember, I have a left pointer, left equals 0, right right equals 4. Okay, that's the index of each of these elements. So if I increase left plus plus, and first before I do any increasing, let's check the left and the right element. So 1 plus 4 is equal to 6. Okay, so 1 plus 4 is equal to 6. I know that, or 1 plus 4 is equal to 5. So that's less than the array, right? That's less than the k. K is equal to 6. Nums of left plus nums of right equal to 5. So what can I do? Well, in that case, since this is less than the target, what I can do is I can move left ahead, because all the numbers ahead of left or to the right of left are going to be increasing. So my best chance of finding a sum that equals the target is moving to the left. I can't move to the right because I'm at the very end of the array, but also because I can't use elements that are past the element I've already used on the right. So the only thing I can do is move to the left. So if I move to the left again, nums of 1 plus nums of 4 equals 7. So now I'm above the size of the target, right? Because the target is 6, right? K equals 6. So in that case, what do I do? Well, in that case, since the only thing I can do really is I can decrease the sum, the next attempted sum, right? And the only way to decrease the next attempted sum, while still taking into account the numbers that I haven't used yet, is to subtract right, okay? And then, so I'm squeezing the right side. Again, nums of 1 plus nums of 3 equals 6. Great. And therefore, I'm going to say my total operations, ops are plus 1. And then what else is there left to do? So I have to move both pointers now. I'm left plus plus, right minus minus, because I can no longer use this pointer and this pointer, this number and this number, right? Because you have to remove them according to the original statement from the array. So with that being said, we have only one number left, 3. And so how do I know that this is the maximum number of operations, that 1 is the maximum number of operations, right? Max ops equals 1. Well, because there's no other way to sum elements in the array such that we can get to the target, and this is the optimal addition, right, of all the elements. So with that being roughly understood, let's attempt an algorithm. So I'm going to call my number ops. This is what I'm going to be returning, int right equals nums dot length minus 1, int left equals 0. Okay, these are my 2 pointers. And remember, what did I say I was going to do? I was going to sort the array. So sorting slows down the progress of this array, but it prevents us from having to do like anything like a depth first search or something even more crazy, because you could do a crazy depth first search type thing to traverse every element in this array and find every sum, and that would just not be efficient, if you can imagine, right? So sum equals. So now I'm going to go iterate through my array, and I'm gonna iterate until left is less than right. If they're equal, then they've obviously come onto the same element. If they've crossed each other, then you're in an even sized array and there's no longer anything you can sum because all the elements have been used. So so we're gonna get the sum of the left and the right. We're summing everything regardless. So if sum equals k, remember what I said, if sum equals k, then we have to squeeze both sides of the array. Okay, we squeeze both pointers towards the middle, right, minus minus. Okay, else if sum greater than k, right greater than 0, right minus minus. Okay, so remember this counts for if we've overshot with this sum, then we need to reduce the next sum by moving the right index over to the left. right? We shrink the right index. And final condition, right, is if left is less than nums.length minus 1, right? Left minus 1. We want to make sure we don't want to go to get past the end of the array. We probably don't even need to do this check, but I'm just doing it anyway. I will confirm if I need to do this check anyway. But just good boundary condition checking. So let's go on. There you go. And let's see what we did here. Left plus plus. We have to do plus plus. Yeah, oops. That test case fooled me. Okay, there you go. Now let's see if we even have to check the boundaries. I mean, I think it's a good practice, but does it speed up the algorithm to not do this extra if? Oh, wow, it actually did by a lot. But you know, you never can really trust Leetcode's thingamabob here. So, yeah, that's the answer. It worked. Runtime O(n) log n, space constant, right? Because we're not doing any other storing of any other elements based on the amount of the nums that we get back. So, yeah, that's it. So if you like this video, like, subscribe, comment, let me know how I'm doing, and till tomorrow, I'll see you around. Oh, and the discussion thread is available. Remember, check it out. I'll link it in the video. The discussion thread I wrote, it's my code. I do the code problem, I learn how to do it, and then I put the discussion thread, my discussion thread. Okay, thanks. See you.